Hello, we're trying to put together a fourth YouTube here. I gave a summary in an email with the different addresses, so you can find it. I hope it's a bit easier, but I'll just run through some of the things and what got this thing going. For many years I've puzzled over a number of issues, and like everyone else assumed better brains than mine had queried the same issues and checked them out before they became an established fact to be taught in school and the basis for future research. This is a photograph of myself as a sort of I think probably about 12 or 13, up in the mountains in Wales. We come across this carcass, and at the time I said, well, how's this going to end up as a fossil? There's no way it's going to decompose. So this questioning isn't just in the last few weeks, last few months. I've been issues of cropping up, and they've probably, but like everyone else, we either don't question it or think it's already been well researched. But these things are taught in school, and they become well, you ruffle a few feathers, and I know about that. And this will either thrill you or chill you. I can't say that these things will go down well with everyone, but why not talk about it? Come, let us reason together. The most somebody said to me was, well, I suppose if you put it that way, you've got a point. I wouldn't say it's changed any seismic switch in thinking, but I hope the following YouTube sites will be of interest to others who have inquired about such things, and perhaps get you thinking, and you'll find the solutions reasonable, or at least considered to be reasonable. The first YouTube is just 3 minutes long. It uses the Dyson vacuum cleaner to demonstrate how any material in suspension self-sorts, and according to its weight. Some of its shape might influence, but it's mainly the weight, and it's used in industry all the time. But it shows all the different layers and the strata that is given to us as an explanation for uniformitarianism. Uniformitarianism, if just to run over it again, was based on the Greek myth, Plutonism. They believed that it's also called volcanism. They believed that the volcanic mountains, the magma erupted, made the mountains, and they were weathered, wind and rain, and washed down grain by grain the mountain back. And so, according to the BBC, they've just ended up, Scotland is covered with the remains of these volcanoes, just a ring at the bottom. All the other bits have gone. Then they believe that's washed into the sea, and that is how we've got all the different strata. There's good sites on the YouTube on experiments in stratification, work done at Colorado State University. Guy Beholt and his colleague Pierre, you'd have to check it up. But this has been around. I've been looking at this for probably 20 years. But it's the basic for the geological column, and it's the circular reasoning because they believe that each layer was layered down one after another, one on top of the other, and that's like counting rings on a tree. And so that must have taken a million years, say. So each layer is a million years, when it's a millionth of a second. I'm not talking, I'm demonstrating. We're not speculating, we're demonstrating. That's the scientific method. It's repeatable, and everywhere you look in the world you'll see the strata. The second one, I did mention things like no ice age and So the second one is titled Age of the Earth, 6,000 years and no ice age. I'm sorry, no, that's not the second one. The second one goes into how rain was formed. In the email we put a letter that we sent to the Dyson Foundation to Sir James Dyson. I called him Mr. Dyson. I'm sure he won't be too happy about that, but he does have school foundations. To take this into schools, it turns everything over. But can we go on just teaching believe rather than facing up? It's the truth. You cannot believe an error and end up believing the truth. You've got to have the truth. The second YouTube is 20 minutes. You use a box of screws and the art sand artifact. You can see how you can demonstrate how quickly the sand sorts itself out. It's there on to see. Explain how gold prospectors rely on that when panning for gold. If you want to wait for the gold to wash down from the mountains over millions of years, be my guest. I'd be following the crowd, panning for gold. That you pan for gold, it washes and the heavy comes to the top. It's got more kinetic energy, I presume. That's just comes to the top all the time. It went into how rain forms and how a 20-foot weight of water on the we're talking about the Noahic flood. 20 foot of water and the weight of that water on the Earth's surface, pressing down on the water table underneath. Once it finds a breach, spews up everything into the air. Splat, it comes down. You'll end up like slag heaps at the coal. You throw it up and you've got mountains, and splat on the life, and that's how you get fossils. Fossils are, as I say, on that photograph of the animal, it has to be oxygen oxidizes, breaks things down. Once it's smothered, you can go and spend a fortune on something to shrink wrap food to keep it longer. That's how you can make things stop deteriorating. So I'm not talking about something that you've never heard of before. What are we up to? The claims that tribolites are always on the ground. There's photographs here of a tribolite on the top of the mountains, and people say, please do not take the tribolite fossils. That's on the top of mountains. The photographs there, there's warning. As I say, all the geological column has to be a cartoon. It's men's imagination. Again, you cannot have an error and end up believing the truth. Tribulized dinosaurs, you end up with dinosaurs. If you go to the Isle of Wight, they only have to have another cliff fall and another dinosaur's bones are exposed. And also it show how some of the layers are so tight. You've got layers and layers for how you get layers of gas and coal, and that's, they can drill for it. They drill down and then horizontal. That's covered in the second YouTube. A mention was made about the Ice Age, and that was the third YouTube. I think that would be called Age of the Earth, 6,000 years and no Ice Age. An apparent universal belief in numerous ice ages over millions of years, even amongst creationists. They talk of one sometime after the flood, which was 2,400 BC, with slow-moving ice carving out valleys, plains, even deep lakes. There's a National Ice Age network. Make sure that the idea I call it, is kept alive. I submitted an article to The Spectator, who invited contributions about the pseudoscience to support climate change. I explain how erratic boulders, the La Mer de Glace, Greenland views, English do you see the YouTube and see whether I'm being reasonable or not? All we're saying is, come, let us reason together. Somebody will say to me, well, I suppose if you put it that way, you've got a point. But that's as far as I've got. Others would say, well, I believe my eyes, but I don't believe you. But there we are. There's some people don't want to believe, and that's up to you. I also point out that glaciers in the northern hemisphere will be produced on the north face of the mountains in the shade. In the southern hemisphere, they're on the south facing side of the mountains. It also goes into how the Ice Age theory ever got started, and there's academic feuding going on as to who came up with this. There's a certain somebody by the name Agassiz, features on Mars and Moon, and the Moon are named after him. He was lauded for it. But then, and I said that the YouTube that will follow will be the relevance of light. We're taught about an unapproachable light. There is a light source, and it's unapproachable. If you know where I'm coming from, the father of light, there's only one source, the source of everything. But the way cosmic rays produce all the matter that we have. And so, that's the summary. So what I started for this fourth YouTube was to discuss the water cycle. Now that is, you would say that was a well-worn path. How can anyone correct? It's so obvious. You've got the water source, you've got evaporation, condensation once it rises, comes down as rain, precipitates down to the rain either on the mountains or the plains, runs off back to the water source again. Blindingly obvious. But my question, but that's no matter whatever the weather. It doesn't, for evaporation we're used to having heat. It takes a lot of heat to turn water to steam. We're not living in that we don't get up to boiling temperature, but nevertheless it's just assumed that. I haven't heard anyone question that. When I was looking at the explanation how rain is formed and how specks of dirt matter is produced for the speck of dirt to be created, for the cloud to coagulate, you've got cloud nuclei and cloud condensation nuclei, and then you end up with droplets. But as I just said in passing, how static electric is registered and gets stronger as the testing rig is taken up into the sky. They took it up into balloons many years ago, and that occurred to me that it was getting near a source of some sort. What's going on up there that we should get a stronger static force? Well, what we have as a benefit, this is just keeps life going. We know how much we depend on the sun. Now the sun emits cosmic rays. Cosmic rays, we're hit millions of times a day by cosmic rays. Cosmic rays travel through solid matter. But cosmic rays are quite dangerous. We can't afford, too much sun doesn't do our skin any good. It'll age our skin. It'll cause cancer. We love to look good, just a bit of a tan, but that's our skin protecting us from the cosmic rays. But we have other things protect us. Our magnet sphere deflects some of the cosmic rays. The cosmic wind deflects some of it. The sun has its own magnetic field, and that draws the cosmic rays and the what's kicked out. I'm guessing I was complicated here, but what it also comes is what's that other ultraviolet light? I just keep forgetting that. There's a saying that the Lord uses simple people to confound the wise. So this is proof of that prophecy. Ultraviolet light breaks up the material, whatever, into plasma. Now we're familiar with plasma. Plasma is what keeps the fluorescent tubes going, and television, we have television screens. Material have 4 states. Water, for instance, has a liquid, it has a solid when it freezes, and it becomes gas when it's steam. But adding more energy to it, you end up with, breaks up the positive and negative charges, and that's what plasma. And at certain parts in the atmosphere, they become free agents, because like poles attract, and like poles repel, and opposites attract. Now, when this experiment I saw, and I'll just demonstrate now, just to show you how water is affected by static electric. We've all done this with balloons. We've rubbed them up, and we know how it'll stick. We're familiar with that. Now, if water is H2O, and H2O is unusual, not unusual. It's 1 oxygen and 2 parts of hydrogen. Now those 2 parts of hydrogen are on one side of the molecule, not equal side. They're astrometrical, they're slightly different. And you have the 2 molecules of hydrogen. Now that hydrogen is positive. And when it comes in contact with something that's got no positive and loads of negative, it wants to come together. Now, just to show how it affects, I'll just create a bubble. Build up the charge, and that'll lead it around like a faithful dog. The forces are there. It's not unreasonable to say any water on the floor, on the ground, will be drawn up to the ionosphere. The ionosphere is where the ultraviolet light has broken down, and it's negative. So there's all this positive looking for somewhere to join up and get together. And I haven't gone into it, but somebody may say, but it certainly explains, because we do not live where we can dry things no matter what the weather. No, not quite, not, but certainly you freeze dry. We freeze dry things. It'll dry in the winter. You can have to be careful if you put food in the freezer. Otherwise, you'll get freezer burn. It dries it out. That's not heat, is it? I mean, it became a big thing when we had freeze-dried food, because they realised that you can dry it, and it's far better than heat-dried food. It doesn't lose its benefits. So, is that nothing? Is that just now another way of testing? We can a little bit of confetti here, rice paper, and these are forces, and everything depends on this issue of positive and negative. It's a lifetime study. It's called particle physics, and it's what everything depends on. Talking about how they say, oh, we're getting dust. This is NASA. They're getting these pictures of dust crossing over from the Sahara to the rainforests of Central America. They seem to think somehow it lands on the Sahara and picked up and taken across in a prevailing wind. I would suggest that it's picked up by the prevailing wind as it's produced in the stratosphere or the ionosphere. There's different. I'm getting tongue-tied, but that dust that we're familiar with all the time. How long did it take before you get a film of dust everywhere? And what do we use? We do a static duster. It just picks it up. It's static. Now, and then when it gets taken by the prevailing wind, it'll feed and nourish, and it's got phosphorus in. It also lands on the sea, and it feeds the plankton, and the plankton feeds the whales and the other fish. And I think there's mention here, millions of tons, 27 million tons on one, 27 million tons crossing over to the rainforests. But it's so fine. I understand it's about the dust is about the 100th of the size of one of our hair. So it's abundant food, it's abundant nourishment. Farmers will say you've got to leave a land to lie fallow because the nourishment is coming down in the rain. That's what you can. I'm sure they won't need convincing. There's so much more to talk about. Photosynthesis relies on separating the water, oxygen and hydrogen. It needs the oxygen to produce the sugars. It needs but if we try to separate it, it would take so much energy, we'd fry the plant. It would be shot, but there's a sun ray comes in, it catches it out. It's a bit like a slingshot, I imagine. Gets it and separates it. If only we could copy that, we could have endless amounts of carbon-14. We could discuss carbon-14. It's often talked about how we use it constantly as some reference to date things, and so we know how the cosmic rays hits nitrogen, and nitrogen it attacks the molecule. It breaks off one, another one comes and becomes carbon-14. The carbon-14, after a while, it's taken in by the plants. Animals eat the plants, we eat the plants, we eat the animals, we absorb carbon-14. So there's a carbon-14 while we're alive, but once we die, the carbon-14 dissipates, and that's a way of dating. So it's something you've never heard of. That is another demonstration of how water can be. This is water, and that's been rubbed static up, and it just deflects the water. I shall leave it there, but we're talking about creating mass, and where mass comes, and this is what the Hadron Collider are doing. They're spending an awful lot of money. They haven't done it yet. You look at what's been done, but nature is doing it all the time and providing us with all this dust and nutrients. It's food from heaven, the heavens, manna from heavens. I know you don't like. You're all very hard to be impressed. I don't know what, but if you're honest, you've got to say this is a lot to give thanks for, and I hope you've felt you know a little more now, so you can defend your position. I am not a preacher. I can't give you explanations, but I can at least. We don't have to be intimidated by science. Science is people will believe myths, as Napoleon of all people said, people will believe anything as long as it's not in the Bible. Come, let us reason together. If you have any questions, I'm very poor at answering them, coming back, but there have been few people watching these videos so far. We've not had any comments, though. We don't know what to make of it. So, thanks once again.